The second part of our study on properties of exponents asks us to consider what happens when we raise a power to another power. So what does that look like? Well, it looks something like this. It would be the same as taking 2 to the second power to the second power. So we're raising 2 to the second power and then doing that a second time. Let's break that down into things we're already familiar with. Inside those parentheses, we see that 2 to the second power, and we all know that that is 2 times 2. And taking that to the second power means we're multiplying 2 times 2 times 2 times 2 again. And we know that that is the same as 4 times 4, or 16. If we have 2 to the second raised to the third power, that's the same as taking 2 squared times 2 squared times 2 squared, or 4 times 4 times 4, and in this case we get a product of 64. 2 to the third power times itself, or 2 to the third power squared, means we're going to take 2 times 2 times 2 and multiply it by 2 times 2 times 2. Well, that's the same as 8 times 8, or 64. Well, wait a minute. Isn't that what we just got when we multiplied 2 to the second to the third power? I also noticed when we multiplied in this first statement, 2 to the second to the third, we used 2 as a factor 6 times. Well, and down here we did the same thing. We used 2 6 times over in order to get 64. So wait a minute, let's look at these exponents. Do you see the 2 and the 3 up here in the exponents and the powers? Well, isn't that related to 6 through multiplication? And down here we see the same thing. 3 times 2, well, that also equals 6. All right, let's take a look at powers of 3 to see if we see that same pattern develop. So stop the video and you try the second column. For 3 to the second power squared, you're going to take 3 times 3, multiply it by itself again, and then go down the column using the patterns you see when we worked with powers of 2. All right, let's check this out. 3 to the second squared would be the same as 3 times 3 times 3 times 3, or 9 times 9, which is 81. And if we take 3 squared to the third power, we should see factors written out like this. Well, that's the same as 9 times 9 times 9, which would be 729. And then if we have 3 to the second squared, that's the same as 3 times 3 times 3 multiplied by itself. Well, and that's 27 times 27. And if you check that, that's also 729. So again, we see that same relationship. We get the product of 729, whether we're doing 2 squared to the third power or 2 cubed to the second power. So that same relationship of 2 times 3 equaling 6, or 3 times 2 equaling 6, exists in the powers of 3 also. So let's take a moment to write that down in our observations. We notice that 2 to the second cubed has the same product as 2 cubed to the second. The same pattern exists with powers of 3. And you understanding that, we can realize that that pattern, that connection will happen with any base, because 2 times 3 is the same as 3 times 2, and that is equal to 6. And that 6 just represents how many times we use the base as a factor in our multiplication. So in order to write this algebraically, we need to first define our variables. So we'll let a be our base again, and we will let m and n be our exponents. And to find the power of that power, we're simply going to multiply the exponents. So a mathematician would write this using variables by writing a to the m times n is the same as a to the m times n. So let's do a few examples together just so we solidify that understanding. We can say that 2 to the 4th squared is going to be the same as t to the 4 times 2, or t to the 8th. We can say that x to the 5th power raised to the 5th power would be the same as x to the 25th, or 5 times 5. And then down here you see k to the 7th squared, which would be the same as k to the 7 times 2, or the 14th power. And finally, a to the 6th raised to the 4th power would be a to the 6 times 4, or a to the 24th. And before we wind this up, I just wanted to point out that anytime we're dealing with the power of a power's property, we're always talking about a number with a single base. Okay, so for example, in this last example, we were only focusing on a. We were only focusing on k over here. But that base is consistent throughout any single problem that we're working with. So this is a good time to review what you've done in this lesson, and then to proceed to the independent practice and to check your work in class. Please let me know if you have any questions.